Mariah asked me to go over was a little bit about REST APIs in Go. And I decided that usually when people give these things, they have a PowerPoint up and there's live coding and all of these things. But one of the things I love about programming is that you actually can go and generally find through Googling and using Bing and things like that. I only use Bing so that I can get rewards, by the way. Through search engines, you generally can find a lot of things out. It's good when you're an introductory programmer. And I believe there is some part of us, no matter how good we are at programming, that is still going to be an introductory programmer no matter what. Because there are always going to be people that know more than you in things. And so I figured what I would do is first provide you with some code here. This is actually a slightly altered version of an intro to REST APIs that is, I believe, linked in my main.go file. And I love how one of my commits was literally typo. So this is a slightly edited version of this create a simple RESTful API with Golang from 2016, which, as I recall, when I first had to learn how to make REST APIs, this is one of the blogs I looked at because my manager at the time was like, okay, I need you to make a REST endpoint. What in the world is a REST endpoint? I have no idea what that is. So I have this for you all to clone or download. Is everyone familiar with Git here? Okay, anyone unfamiliar with it? Because I'm totally happy to go over Git stuff. All right, looks like we're good. So this is an interactive example of a REST API. But before we get to that, we should probably define what a REST API is. Does anyone already know what a REST API is? I know Robert does. Robert, I want to see if your explanation is better than mine. What would you call a REST API?
Oh, thank you. A REST API is using the internet's existing capabilities to communicate between running applications.
Yeah, that is a pretty good definition. That is basically the working definition that I had going into this.
And that made no sense.
It was, hey, this is something that I can call and I can do stuff. That is the most basic definition of a REST API. However, it actually is an acronym, and it's a horrible acronym in my opinion. It's representational state transfer, which I will be completely honest, I had no idea that that was what REST in REST API stood for, and I was making them myself. So the acronym is not super intuitive. I would say I wouldn't exactly know what it's talking about just looking at the words representational state transfer. But what it basically is like Robert said, a way to communicate with a representational state transfer, which I'm just going to call that REST for the rest of the day because I don't want to say that word again. It is an easy way for systems to communicate with each other. So with a REST API, your server and client don't have to depend on each other. So like a REST API can generally be thrown into whatever you need it to go into. For instance, if, I think I can make this a little bit bigger as well if that is needed for anybody. I might be able to open it on this. So basically, a REST API, what's cool about it is that you can call it from pretty much anything, and you can take the answers that it gives back and use it however you want to. So for example, I am going to run this REST API here on my terminal, which I believe is running already, but I'm going to close it. Okay. So this is a Go run. You've probably seen that before. So when I go to that, oh shoot, I need to figure out what my host name is on this in order to see it. So hostname -I, still have the same host name. So now I'm going to run go run main.go, and I'm going to call this REST API I have here, and we will see it in first my browser, and then I'll teach you a little bit about Postman, and we'll talk a little bit about what the code that I have here is actually doing. And then we can just kind of sit and talk about things, ask questions, whatever you want to do with it. So, giving an example of this, this is, if I go to localhost 12345/attendees, we should see, oh, that's so mean. Because I can explain what's going on here. This is actually because the Pixelbook has the Linux backend separate from the rest of the machine. So I technically have two different machines running. So I need to put in 100.115.92.200. 5.92.200. Because this is my IP address, and the code that I have here opens up a port on 12345, and that is where this simulation of my REST API is running. So if I go to that, what is happening here is this is a GET call. This is something referred to as CRUD operations, which we can talk about that a little bit more. But this is an example of something output from a REST API. So when I'm getting into, you can use the output from a REST API for pretty much anything. You could take this and you could create an entire web page around what this returned. You can go, and if you're like me and my husband and you're playing Pokemon Go lately for no good reason, you can go and you can access their open APIs and be able to, for instance, make a Pokemon Go Plus, which is what people can carry around and get Pokeballs thrown at Pokemon. And that uses that API. It'll say, hey, throw a Pokeball. So the access that what I'm calling right here is literally just what has been put into this little database of attendees to this meetup. And right now I've only put myself in.
Can I ask a question?
Yeah, absolutely.
So would a REST API be considered like portions of a site's data they're allowing anyone to access? Like,
to an extent,
Reddit,
yeah.
right? Like you can go
So,
in Reddit's
yeah,
endpoints and pull data, or you can go to like financial data and pull stock data.
yes.
But it's like portions of their site they're allowing access to.
Yeah, a REST API is you can have private REST APIs that are used within a company,
Okay.
but oftentimes what you'll see in the examples that I've given are public REST APIs. And so one of the things that we talked about that I mentioned about a representational state transfer is that because the client and the server are completely separate from each other, you can do pretty much anything with the data you get back. So what I'm showing you right now is a response from a server. One of the things I talked about with something called Postman. Postman is a client that you can usually use to test your backend APIs, but you can also put a front end onto these APIs. So for instance, when Robert and I worked at Inside Sales, his team worked a lot on the front end, on some of the front end stuff for the REST APIs that we were making and consumed our REST APIs. So it's an interesting way to work together as developers. And I think what I think is really cool about REST APIs is that they really can build the backbone for a lot of development, especially now as we're getting into this age of, cloud development, big data. You see people needing to communicate and needing to be able to share things. And overall, my biggest thing that I would say a REST API can do for you is help you to be able to share data. Okay, does that make sense to everyone? Does anyone have questions? I know I might be a little off today. I'm a little loopy. I'm not gonna lie. I'm on a bunch of cold meds at the moment. But hopefully this is making some sense. Does anyone have questions before we look at the code and kind of go into what makes up a REST API in Go? All right. So let's take a look at this code. So how many of you have made a struct in Go? You made structs before? Okay, structs are kind of like the almost object-oriented part of Go. So right here, we just have a person struct, and it's communicating through JSON, which JSON and XML are the two, what do you call them? They're kind of like HTML. They are markup languages. They are the two basic languages that most REST APIs communicate through. I find JSON to be easiest, but I also know in front end, you mess around with a lot of XML, at least the front end that I've played with. So what happens here is we have this struct of persons, and we have this, does this need to be bigger for anyone? Okay. We have this variable of attendees, which is an array of persons or a slice of persons. And then we have these functions that are all of our endpoints. An endpoint is specifically just the one piece of the API you're wanting to hit, or it's just one specific function. So for instance, one of my favorite things to go through is the Go by example tour of Go. And near the very end of that, it covers how to make an HTTP endpoint in kind of a hello world-like way. And that is what all of these are. REST APIs tend to be a collection of various endpoints that have functions attached to them. So with this get attendee endpoint, this is getting a specific attendee out of our list of attendees by their ID. So if I wanted to call this, I would go into my Chrome and I would say attendee, I believe it would just be this. Let's see. Nope, I forgot how, oh, Q. So we need to put a query string on this.
Oh, you got it. Yeah.
Yeah, it's the question mark, then the Q.
Yeah, there we go.
Q, and then ID equals 1.
There we go. That makes more sense.
Still need the Q.
Yep. Thank you. No.
It's Q instead of ID. There we go.
Nope.
No.
Okay, we'll look at that in a second because I can't remember how to call these without Postman because I'm used to calling things through Postman.
Ease.
It really depends on how you're making your API. So with an API, there tend to be, we follow the parameters of HTTP. Gosh, what is the word? It's HTTP rules. So the standards, HTTP standards. So we follow those standards and they have headers, queries, parameters, requests. And so the various requests that we have are defined by CRUD, which is create, read, thank you. I couldn't remember read, create, read, update, and delete. So if, as you can see, both of these gets are read functions. The create is a create and actually an update. You'll usually find that most creates tend to have update mixed into it, which this is right here. It decides, hey, if the attendee is already created, we're just going to update that attendee. So if you already have an attendee named Tatum Sims, we're going to go in and we're going to update whatever additional information you put in there. There is delete. And then we have our main function, which is actually the juicy nitty-gritty of how we do this in Go. This specific code is using a library called Mux, Gorilla Mux, which I find to be a lot easier than the HTTP clients. However, you can figure out how to make a REST API using the plain old HTTP client from Go. It just takes a little bit more work, and the router in Gorilla Mux is a little more robust. So what this router does is we have, it creates a new router, and then it creates these endpoints along with the slash whatever verb you're wanting to use, whatever word you're wanting to use, like attendees. And where it says handle func, we're able to say, hey, I want to use this verb to access this specific function, and I want to apply the get method to this, or I want to apply the post method to this. And then at the very end, we are listening. The router is listening and serving this API on this specific port. And this is honestly one of the most basic ways to create a simple API.
It's kind of a scary line at the bottom, you know, log.fatal.
Log.fatal.
What does that mean?
The log.fatal, honestly, I don't entirely know. I know it means that it will let you know. Actually, I do know. It lets you know when it's not working and when the server has stopped. And so what you're doing is you're setting up this server. If it doesn't work, we're going to log it to the terminal so that you know why your router isn't starting, why your REST API isn't starting.
And when you hit Control-C,
that also
passes it to.
Yeah, that also puts a keyboard interrupt log in there.
Yeah.
So what I want to show you is Postman, which I have working in Linux here, but you can get running on Windows, Mac. It's a pretty useful software, in my opinion. It makes it a lot easier to be able to figure out how to use a REST API. And this one I actually can say localhost since this is running on the Linux end. So if I hit send, as long as my server is still running, yes, we get putting humanity into computing. If I go like this, and I say key ID, value equals 1, then we actually get the correct way to make this request in the get portion here, since I couldn't remember how to put the query parameter. Let's see, this should also return.
I don't think you put it as a query string. I think it's just a param.
Did I just put it as
ID.
Yeah, you did it.
Oh, did I just put it as params rather than a query string? So it needs to go into the body in that case.
Or just change your get.
Yeah, I could do that too. Oh yes, it is a params. Okay.
And looking at the roots at the bottom, you can see it's just slash and whatever ID.
Sorry, looking at what?
Right
Oh,
there.
Yeah, it's not.
Slash.
Yeah.
Oh,
So you're just
slash
sending
ID.
in.
Oh,
No.
that's right. This is what you get when you're basing your code off of someone else's stuff and you don't entirely look into it. So that is my bad.
Now, the thing is, what you have there is very important in REST.
Yes.
What you have there is a noun. And you're saying, I want attendee 1.
Oh,
And,
and it's all attendees, not attendee. Okay. That's why.
okay, attendees. And so you're saying, I want attendees,
There we go.
or I'm saying, attendees 1, I want to get it.
Yeah.
That's all that REST is about, is it's saying, your URL is the noun, your get, post, put is your verb.
Yeah. And if we wanted to say, go into a post, and let's go post, and we'll say attendees 2. And we would go into, we would actually want to make a request form of something.
You accidentally hit 1 instead of 2.
Did I hit 1 instead of, oh.
That would be bad.
So we'll want to create a person. I always end up copying these because otherwise I never remember what the JSON data is. So let's say, first we have ID. ID. And interesting that it's a string 2. Oh gosh, it's been too long since I've done this.
Colon after ID.
Thank you. This is what I really should have been working on today, rather than shoveling cold medicine into myself. Okay, first name.
We're forgiving.
I appreciate that. Let's say we're going to put Olivia on here. And last name.
Is there something about the JSON information there that indicates how to send it? Because are you doing lots of little objects inside of the outer object on purpose?
No, I'm not. You're right. There we go.
Oh, yes.
That was my brain fart. Like I said, I knew I would have many today. But thank you for being forgiving. Okay, what's your tagline, Olivia?
Tagline. Do hard things.
Do hard things. Okay. This is the moment of truth, guys. Let's see if it works.
The 200.
Oh, look at that. We have 2 people in our attendees list now. All right. So I think that showcases some of the fun of things you can do. I could also decide to make this a delete call, which you will pretty much never see a public API that has a delete endpoint, and even most private API. Yes?
Oh, sorry, I didn't mean to interrupt you, but I was just curious, where are you storing all this on the back end? Like, where are you storing the attendees?
So you could store them in a database. This is literally just being stored in a slice right now. So this is the most basic API you can make. If you're really wanting to make something awesome, you'll probably want to get a database, get something to put your data into where it'll stay persistent. So this is...
Could you do that with AWS?
Yeah.
And then use Postman?
Yeah, you could. That was most of what I did when I was at Avanti, was figuring out how to make REST APIs work well with AWS and S3 specifically. So you can put things into S3, you can put things into DynamoDB. You can also use open source solutions. It's totally great. There are lots of places where you can put your data. If you're really wanting a lot of data, you'll have to pay for it. But if you want not very much, if you want just a dummy API, you shouldn't have to worry too much about it. So, yes?
Can we look back at your struct there for type person?
Yeah.
Okay, so what is everything in backticks?
Okay, so this is specifically JSON tagging. So this is how Go knows how to communicate with JSON, how it understands how to read what you're giving it. So what this is saying is our JSON tag is going to be ID, or our JSON tag is going to be first name, rather than this piece in the struct, because Go doesn't automatically know how to read JSON. So these backticks make it so that you can, one, have some documentation in here, and also be able to convert structs into JSON and between JSON and structs.
Okay.
So the omit empty here, that just says that if I don't include ID or first name or last name or tagline, it's not going to put it into my slice. It's just going to make a person with a blank whatever that was that I didn't include in it.
So if you left it out and you wanted to add another attendee, and let's say you didn't put a first name in because you said it was a type string, would I get an empty string, or would they just have no first name field?
Well, let's check. Because it's been a while. So let's not delete. Let's actually put a post. Robert, did you have something extra to add?
I was just going to say is if you don't have the JSON colon and then the tag name, it will default to what is in the struct. And so if you used capital I, capital D,
Yeah.
it would work.
Yes. But JSON, there are JSON standards, and with JSON standards, everything should be lowercase, which is why generally we document those after within our structs. So let's say we even will say people, not employees, because that is the billboard I pass every time I come here.
And remove the first name altogether.
Yeah.
Oh, just remove the whole.
Oh, okay. Don't include it at all.
All right.
Okay.
Okay, and we got it, and it says.
No first name.
First name. Okay. Cool.
So with the omit empty, there are various things that you can go into with the JSON tags in Go. I know that omit empty is one of them. JSON tagging Go. Let's look into where the standards are for that. Okay, this is part of the JSON marshalling package. And so I believe it is in here, Golang spec. Because I know some of the other tags for it are, I believe you can set it as required, and then you can include a let's redirect to something if they don't put this in correctly. You can add error messages. This particular API is very, very not robust. What is the opposite of robust? Simple, very simple.
Brittle.
Brittle, yes, brittle is a good one. But this is basically a good place to start. What I recommend is if you want to play around a little bit with APIs, you can download this simple RESTful API and you can add your own error handling in there. Some of the things that I put on the things to explore on the whiteboard is there's something called Swagger that you can use for documentation, which I remember I had the worst time trying to get Swagger working with my code at one point. But I know that things have gotten better now. So Swagger is one way to document your APIs so other people can use them. There are plenty of other libraries that make it even easier than this to make an API. There are ways to throw the front end on and have a front end consume whatever you're doing. So if you want to do a little bit with JavaScript or even with, I used Dreamweaver a long time ago when I was in high school. If you want to use some simple website making tool, you can use that to consume your API. There's also details on how you deploy these APIs, which that's where things get a little more complicated sometimes. Oftentimes you'll have people put things in containers, which is where services like AWS can come in handy. And then there's putting security on here, because right now this API is not secure at all. And especially if you are going to be exposing certain data that might be confidential or personal, you'll want some way to make sure that the right people are accessing this and aren't figuring out some way to take down your site or steal data or any of the various hackery things that people can get into. Yes?
Can we look at the create attendee endpoint and just kind of talk through how we get the body and then we take that and it meets
Yes, okay.
JSON
Is
instructions.
it the JSON
left
new
in the struct there?
Is it the JSON new decoder part that's especially confusing?
I mean, I would love to walk through it line by line.
Okay,
And all of it.
so what this is doing originally is this is the params here where we create attendee. Mux is our router that we had before. So Mux is able to actually go into this request that we see here and turn this into parameters. So mux.vars creates the parameters in the type that they are mentioned in this struct. And then we have this var person, and here where we have JSON.newDecoder, a request has several pieces. Like if we are to go into an HTTP.request, one of those pieces is body, and body is the part that you want the most. Some of the other parts are the bytes. So if you were to use the bytes of the request, you could find out the size of it. So if you wanted to limit certain requests because they were way too huge, you could limit that based on what the byte size was of the request. But this JSON.newDecoder is basically where we are able to convert the request body into the person struct. So new decoder decode is actually the way we're able to take that struct. Another thing you can do is JSON marshalling, but I have found that decoders and encoders tend to work better for simply transferring structs and their request bodies between the various formats. And then what we have here is setting the parameter to the ID of this person. And then we are, by that ID, we need this ID to be set as the parameter for this struct so that we can actually sort our list of persons, which is why we have the parameters ID that we're setting here. Then we append it to our slice of attendees, and then we encode it back into JSON. Does that make sense?
Yeah.
Okay.
Let's see.
And this W here is
Yeah,
the response writer. So this encoder here, when you put new encoder W dot encode, and then you have your object, what that actually does is it writes that object to the response writer, which is what you see in your client, which is the response you get back from your REST API. You're welcome. Any other questions about this? I think REST APIs are super cool. They're fun to mess around with mostly, and you can make some really cool projects with them. I know one of my favorite things to do, one of the things that I did was actually create an API to try and help me with my ADHD. I didn't get very far into it, but it's really fun to be able to see what you've made respond to you so quickly. I think REST APIs are kind of taking that joy we get out of code and putting it more immediately accessible to us. And it's also a way to share your creations with others. So REST APIs are cool. You should make them. You should learn about them. The more you know about them, the more you can put them on a resume, knowing the skill of making REST APIs, the more often people go, oh, that's a skill that I want. That's a skill that I want you to have. They're cool. That's, yes.
So this is you making a REST API that.
This is me making a backend of a REST API. What makes it RESTful is that it doesn't have to be affected by whatever is on the front end. And because it has this get, update, create functionality. That's what makes it RESTful. You could technically make any endpoint at all. And if you really wanted to, you could shoehorn it into the definition of RESTful. But to be truly RESTful, it needs to be stateless, so that the API, so this isn't truly stateless because we're saving the state of the attendees here. However, if we have a database in the back end and it's updating that makes this truly stateless. Yeah.
Because I've played around with APIs a little bit, but I've more made a request to ping a public API.
Yes.
Return data.
Yeah.
So is this like that public API that you've?
This is like the public API that you would call, and then what you've been doing is the client side stuff. So this is more the back end portion, and then playing with the responses from the REST APIs is very much building the client that handles it.
Okay.
So, yeah. If anyone has any more questions or wants to play around with it a little bit, we can do that. But I think that is pretty much the basis of what I wanted to go over with REST APIs today. It's a very basic introduction. There are a lot more things you can do with REST APIs. And I encourage you to definitely go out, check the source code that I initially used for this. That is in this comment at the top. It goes over a little bit about each of these functions a little bit more. So if you're really wanting to understand why do each of these points do exactly this, that is a good place to get that documentation. And keep exploring. I think that's one of the greatest things we can do with code. And the more we explore, the more we can make. So,
Yay! I'd like to ask another question about the post there.
yeah.
Just to better understand how the body is getting passed along, I guess.
Yes.
So
Yeah, it's a little confusing, isn't it?
it seems like Mux is doing a lot of the work.
Mux is doing a lot of work.
The type method you're using, and it just knows how to process that or something. I can't
Yeah, I've had to actually go through and create something that will go through each part of the struct and do some error handling to form it into each part of the JSON request and do some error handling to check whether it's actually legitimately what we want it to be. It can get pretty complex. That's why libraries like Mux are great. One of the things you can do, especially, I believe if you have Visual Studio Code, at one point I was able to, darn it, I don't understand how to use it on this anymore, but you can explore these functions a little bit more and see a little bit of what they're doing. But from what I know of what I've built before, you can get some crazy error handling with your JSON structs. And that's a lot where the security portion of things comes in. Being able to, from a really secure standpoint, know that something's a social security number or something like that. It can be, or knowing whether the client is returning a valid JSON struct. That is one of the most common errors that you'll get. Like when I was trying to form this in Postman, if I had still left on, the double braces that I had on everything, that could have caused issues. And those are the kinds of issues that this mux.vars is sorting out. Does that answer your question a little bit?
Yeah, in part, yeah.
Sorry, it's mostly a go into it and explore it, but I can't say that I know Mux super well. Oftentimes, I know enough to use whatever I'm using, and until it becomes a bug, until it starts throwing me issues, I'm happy with it as long as it's something that lots of people use, like Mux. Might not be the best practice, but it's a practice. All right. Well, I'm your coder. Thank you. Thanks for listening to me spiel on and putting up with me not having a PowerPoint. I don't know whether you all like that more informal, no, you prefer PowerPoint.
Oh, no, I was
I
saying
like that.
they rarely add that much, so yeah, you're great with that one.
All for death by PowerPoint.
Yes.
That's per by PowerPoint.
Yeah, I get real thing.
My cold medicine is wearing off.
Trying to get
Yeah.
TV over there.